Comina, Cruz, Davis, Echevarria, Foster, Cusel, Jackson, Darrell, Koliak, Lewis, and Lewis, Lowe, Marshall, Morales, Murphy, Pierre, Nelson, Perry, Robertson, Robinson, Skiro, Self, Surf, Snurl, Stevens, Wade, Wilding. Raquel Wade. Ready for the weekend? Not there yet? So remember how I'm only here on Monday, Wednesday, Friday? Yeah. I'm here every day. There could be worse. Any questions on anything? I have a question. Why shouldn't you tell secrets in a cornfield? Too many years ago. All right. So 8.6 is today's Towards Me teaching lesson. It's all about the properties of our number system. So a lot of the ideas here are going to be more definition based. And it's just so that you can understand some of the small little details that you may have been taking for granted in our number system. Okay? The words here that we're going to use are just going to spring out ideas of things that you probably already knew and maybe just didn't focus on very much. Okay? But some of these things will help you expand your idea of our number system for later algebra techniques. Okay? So the first one that we want to talk about here is this word. What's this word right here? Say it again. There's no N in there. Yeah, commutative or commutative, right? It comes from the word which means to what? Travel, to get around, to move somewhere, to physically change location. Okay? That's important. The commutative property is all about changing the location of something without changing what you're actually doing. Okay? So for example, use the commutative property to complete these two statements. 7 times y is the same thing as y times 7. This is a property you already knew from your times tables, right? 2 times 3 is 6, 3 times 2 is 6. This is the name for that. The ability to physically change the order, the location of where something is in your expression. So what's this next one? X plus 2, right? I'm changing the order of them. Notice the two operations that we're doing there, addition and multiplication. And technically in the key terms, in the definitions up here, they each have their own property. The commutative property of multiplication, commutative property of addition. Right? What about subtraction? Why don't we have a commutative property of subtraction up there? Exactly right. Subtraction doesn't have the ability to switch the order and keep the same answer. So it doesn't have a commutative property. I can't do 5 minus 7 and expect 7 minus 5 to be the same thing. They're not. One's 2, one's negative 2. Okay? Same thing with division. Right? 12 divided by 4 is 3, but 4 divided by 12 is not 3, it's 1/3. So you can't switch the order on everything, hence why it's important for us to have this name of this property. Okay? Now, next, the associative property, coming from the root word to associate, which means what? Grouping things together, right? Who do you hang with? Who do you associate with? Right? Or if I give you an idea, what other ideas do you associate with that? Right? If I say driving, what do you associate with driving? Car, gasoline, right? Things that go together. Okay? So the associative properties of these two have the same connotation. All right? It's about doing something in a different order, but without switching the physical present order. Okay? The associative property is about moving grouping symbols. Right? To associate, right here, is all about grouping. So a lot of times it's moving parentheses, not moving the actual object themselves. So the associative property here, I'm still going to write the 5, the negative 3, and the 6. The order doesn't change. Okay? The order doesn't change. But instead of having the parentheses around the negative 3 and the 6, I'll have the parentheses around the 5 and the negative 3. And according to our order of operations, that changes the mental order in which you work. But since they're both multiplications, it really doesn't matter which one you work, because it's all going to be the same thing anyway. Okay? But sometimes, in some of the methods that we do, we may have to switch a grouping like that. Okay? So what would the next one be? What would letter B, what would the answer be there? Negative 2 plus parentheses 7 plus 2. Yeah, like that. Okay? What about the next one? There you go. Q plus parentheses R plus 17. Okay? And then what about this last one here? Yeah. So A times parentheses B times 21. So here's a question. Oh, well, I mean, if there's different operations, these don't apply because it's the associative property of multiplication. So it has to all be the same thing, right? Here's a question for you. Would it be wrong for me to rewrite this A times 21B? Because isn't B times 21, 21B? Would that still be the associative property? Right, which property would that be? The one that's commuting, right? The commutative property would be this one. This is associative the order of the terms didn't change, right? I changed my mental order, right, by asking the doctor. Mental order. Bring coffee. Okay, so enough jokes. I didn't change the physical order, so that's associative, right? But this one's the commutative property because I didn't switch the physical order. So this is not the associative property that last one. Okay. All right. So then in A and B, it's not asking you to rewrite it. Now it's giving you the complete statement, and it's asking you to identify which of those two properties it is. So in letter A there, 5 times parentheses 4 times 7, and 5 times parentheses 7 times 4. Which property would that be? Commutative, yes. Okay. And then what about B? Does the physical order change? Negative 2, 4, 9, negative 2, 4, 9. Right. The parentheses change there. Right? And this is giving you practice on doing that too, right? Math is its own language with its own symbols. Questions so far? Now let's simplify. Okay. So there's a couple of ways that we can go with this. I'm just going to go ahead and do it the step-by-step way with the properties so that you can see what they're trying to get at here. The first thing I would notice is that the two that I can actually combine are the -3 and the 17. Because I can't add a letter to just a number. They're not like terms, right? So the first thing I realized with that grouping is I need to get those two together. If I do the associative property right now, that moves the parentheses to here. X is still grouped with a number. That's no good. So the first thing I'm going to do is commute. Right? Now I've got the physical locations of the like terms next to each other. Next, I would associate. Or, in a way, you're reassociating. -3 plus 17 is something that I can do. Right? Hopefully they didn't change that one on you yet. I went to the meeting yesterday, -3 plus 17 is still 14. Okay? 4 times 5x. How would I simplify this one? Would I commute or associate? Do I need to switch the order, or are the two things that I'm going to combine already next to each other? They're already there, right? So I don't need to commute. Don't need to move them. I need to reassociate the two here, right? Yes. So that's what I'm going to do. All I did was move the parentheses there. And then, of course, 4 times 5. So that only required an associative property. Okay? Use the distributive property. What is the distributive property?
Multiply everything that's outside of parentheses to A with 5 times X and 5 times Y.
Exactly right. The distributive property in generic form looks like this. I'm basically taking a multiplication and giving it to every term inside of some sort of addition. Okay? Now, alternatively, you can do the same thing with division and or subtraction, any combination of that. Because multiplication and division are constructed similarly, addition and subtraction are constructed similarly. Okay? Also, I need to go ahead and throw this little brainworm in there. We're going to see a distributive property again later this semester that doesn't look like this, but it's still technically a distributive property. So kind of like with the ones we were doing before, you know, there's a commutative property of addition and one of multiplication. And there's an associative property of addition and of multiplication. This is technically the distributive property of multiplication. There is also a distributive property of exponents, which we'll get in chapter 5. Okay? The link here is that I'm doing a one-level jump in my operation, right? Think about PEMDAS, right? Purple eggplants make delicious afternoon snacks. Where is multiplication in relation to addition? Where is multiplication in relation to addition? It's one level of importance higher, right? That's a one-level jump. That's where distributive properties will work. Okay? So as you can tell, I would also be able to do distributing exponents over what? Over multiplication. Not exponents over addition or subtraction. That's too many levels. Okay? But right here, what we're doing is a one-level gap. And that's where distribution is legal. The reason for that is because addition creates multiplication. That's why there's a one-level gap requirement. Addition creates multiplication, right? What does it mean to do 5 times 4? 5 4s all added up, right? Addition creates multiplication. That's why this property works. Okay? So right here, as was suggested, I'm going to do 5 times x and 5 times y. When you have a negative attached, don't forget to distribute the negative along with the number. So I have negative 3 times 2 and negative 3 times 7x. Negative 6 minus 21x. Or you could put plus negative 21x. That also works. Okay? Try the next 4. Well, rather, the next 3. We'll do that. Try those next 3. Did anybody come in after I called Bill? Louis? Okay. Nola? Nola? Anybody ever try eating a clock before? What? I wouldn't recommend it. It's very time consuming. Maybe. Very good. So she multiplies 4 times all 3 terms. 4 times x is 4x. 4 times 6y is 24y. 4 times negative 2z is negative 8z. Okay? How about the next one? Anybody? There you go. Perfect. Okay. Letter E, anyone?
Nice try.
Good catch. Yeah,
I guess it.
you got to get used to the light. All right. Okay, so on this one right here, a negative 1 being multiplied into both pieces. Negative 1 times 3 is negative 3. Negative 1 times negative a plus a. And down here, even though it looks slightly different, is it actually any different than that last one? Because what's the understood number right here? 1. Yeah. So negative 1 times a, negative 8. Negative 1 times a is negative a. Negative times negative gave me plus b. Okay, and then we have the last one here, a fraction. Oops, already F word, sorry. Does it change anything? The fact that it's a fraction? Fractions are numbers too, don't they? So 1/2, I just need to be able to perform the multiplication here. It's 1/2 times 2x and 1/2 times 4. Do I do the 1/2 times the 9?
No.
Why not? Yeah, it's not part of that grouping, right? I'm only doing the distributive property to get rid of those parentheses. That's really the reason we use it so much, to get rid of groupings. Okay. Say again? Go ahead. What was it? Perfect. 1/2 times 2 gives me 1, and 1/2 times 4 gives me 2. But then I actually can go one step further, can I? Absolutely. So I get x plus 11. Questions on anything that we've done up to here?
Oh, I do.
Go for it.
So, I get that we can do 4 times 6y, and I do, but I do want to do 4 plus 6y.
No. Because they're not like terms. If I try to do 4, right? If I try to do 4 plus 6y, right? It's like saying 4 something plus 6 something else, like 4 apples plus 6 bananas. I can't just magically make that 10 fruit. There's no way to change the letters, right? Just like if I did 4x plus 6y, there's still nothing I can do.
So what is number?
Oh, because in multiplication, technically 6y is 6 times y. And since they're both multiplication, I can reassociate the 4 and the 6. All right. Okay, so more distributive property, but now let's talk about how we could do the opposite of the distributive property. didn't even bother simplifying here. What they want you to do is to rewrite this like the distributive properties that we started with before. So for example, I'm noticing right here that a 9 was given to both pieces. So it must have been originally written like this. Right? The 9 was on the outside before it was distributed. And then I have the 3 and the y that were originally grouped. Okay? So what's the next one?
For me,
Right. Or parentheses, x plus y. Okay? Whenever I unmultiply something like that, I'm actually performing something called factoring. So this is actually a very early stage of what we call greatest common factor. The distributive property is multiplying it in, and GCF is taking it out like that when they have something in common. Okay, now they want you to name the property. Okay, so what do we got? What's this property? That's distributing, yeah. Okay, next. Commutative of right. Okay. Substitute of right. Be careful when you're abbreviating these things. You don't want to make an ass out of multiplication. Next. Did the parentheses move? So it didn't reassociate. But what did happen? The order changed, right? So what is that? Right, that's the commutative property of addition again. Yeah. Okay. Now that letter E there and letter F are two that we haven't talked about yet. Okay, so let me go ahead and write the names of these. This is called the identity. Well, no, let's not go that route. Let's just call this the inverse of multiplication. And we'll say this one is the identity of addition. Okay, now let's talk about that for a second. Anytime you have an element in your number system that when you perform an operation with that element and it doesn't change anything, it's called an identity, kind of like identifying oneself. Okay? So for example, in addition, adding 0 to something doesn't do anything, right? So 0 is a certain element, and when I perform this certain operation with that element, absolutely nothing happens. It's like I'm identifying X here in my number system. So anything plus 0 equal to itself, that's called the identity property of addition. And it only works with plus 0 for that one. What would be the identity of multiplication? Right, times 1. It doesn't change anything. Okay? Now, since we've already defined that, any operation that results with an answer of its own identity value is called an inverse. Okay? So in other words, a multiplication that results in 1, since 1 is the identity of multiplication, 1 is that value that doesn't do anything when it's multiplied. Since 1 is the answer to a multiplication, then these two must be performing some sort of opposite. In this case, inverse is division. Right? Or here's another example. if I had 2 plus negative 2 equals 0, this would be the inverse of addition. Because it's an addition that results in the additive identity, 0. Okay? And you can kind of just tell. When two things are canceling out is what you're traditionally calling that. That's going to be some sort of inverse property, right? 2 and negative 2 are opposites. 3 and 1/3 are going to reduce to 1, right? You can tell that that's some sort of inverse, some sort of one thing undoing another. That's your hint from that one, too. That make sense? Questions about those? Okay. Oh, we got one more there in letter G. This one right here.
Commute.
That one actually is both, right?
Yeah. Yeah. In what order? See, because I'd have to reverse these first, right? Because of the way they're associated. This is what they did. They went from here to here, and then from there to here, right? And then that's this side up here. So it's a 2-step, like the one we did a little while ago, right? First, they do a what? What step is this? Right, it's commuting, right? Okay? And then reassociate.
Yeah.
And then that is equal to the other side. So that's 2 different properties, but both of multiplication. So changing the order is commuting, changing the parentheses is associating. Yeah.
So with G, the first one, well, the second one, would that title be reassociate, or what is it?
No, I'm saying, instead of saying the title of the property, I'm naming the action, but they're actually the same thing. You could say right here, associative of multiplication. That's the property that we're employing, but then I'm taking it from the gerund aspect of the sentence, right? This is the action that I'm doing.
Verb form.
The ing gerund. I'm doing gerund. Gerund phrase. So I've had this problem lately with my dog chasing people on a bike. Anybody else have the same problem? Yeah. I mean, it got so bad I had to take his bike away.
What? No, what?
All right, guys, that's the end of 8-6 and my torture for today. Y'all have a good weekend.